Now we will work on how pointer increment operation and pointer decrement operation is going to work. Okay, so first consider a variable here, and its value is 50, and I'm considering another pointer variable star p here. So p is equal to address of x. Okay, now you can print here the corresponding address for x, which is nothing but p. So printf address of p, okay, or address inside p, address which is stored inside p. Okay, so you can display it by writing like this: address of x is so you can use percentage u in order to display this address unsigned. Okay, so p you can display. Now let us run this and see the result. First of all, you can see this is the current address of x is so this is the present address. Okay, now I want to increment this p by one location. Okay, so p equal to p plus 1 represents incrementing by one memory location. Okay, so address is equal to address plus increment by one memory location. That memory location is equal to size of integer. Okay, so p gets incremented by size of integer. Okay, or I can say 1 into size of integer is incremented by 1 into size of integer. Suppose if I am taking p plus 2, then it represents 2 into size of integer. It will get incremented. So finally, when you want to display here after incrementation operation, okay, after increment address is, okay, so using percentage u you can display the address here. Okay, and you can start displaying it. Clear? Now let's run this code and see the result. Okay, so if you want we can display in a single line. You can observe this is the address of x, right? Okay, and after performing one increment operation, address is exactly incremented by 4 because the 4 is representing size of one integer memory location. So that is why it is incremented by 4. Now if you consider incremented by 4, for example, then this represents p has to be incremented by 4 integer memory locations, which is nothing but 4 into size of integer. P gets incremented by 4 into size of integer. So after incrementation, address is you can print here. So let's run this code and see the result. So initially it is last two digits, you can see remaining all are same. Last two digits 80, and here the last two digits is 96 because the difference is 16. Okay, it clearly indicates we are incrementing current address by 4 memory locations, and each memory location is equal to the size of integer. Okay, and size of integer is 4 bytes. So 4 into 4 is equal to 16. That is why it gets incremented by 16. Okay, and now similarly we will consider for decrement operation. Okay, so if you want to consider for decrement operation, okay, so let us modify here to decrement operation, and also here I'll perform p equal to p minus 1. So here p will be decremented by 1 into size of integer. Yes or no? So p is equal to p minus 1 represents p will be decremented by 1 into size of integer. And after decrementation, the address will be like this. Okay. So let's run this code and see the result. You can observe the address of x is last two characters, you can see 80. Now decrement it by one position, which means one memory location equal to the size of integer, which is 4 bytes. So this should be decremented by 4. So value becomes 76 like this. Okay. And then now, for example, if you want to decrement by 4 memory locations, then p is equal to p minus 4, which means p will be decremented by 4 into size of integer. Size of integer is going to be 4 bytes. 4 into 4 is equal to 16. So p should be decremented by 16. Okay. So let's see here. So this is 80 and this is 64, last two digits. Okay, remaining all are same. So it is clearly getting decremented by 16. Okay. So this is how pointer increment and decrement operations will take place.